Okay, a hearty hello from West Virginia. Or not. Well, anyways, what I do have, though, what I'm confident about is Joke of the Day, because we've been waiting for Joke of the Day. Are you ready? This is a great one. So this guy is taking his girlfriend to the prom, and he goes to get the tickets, and the ticket line is really long, but he ends up getting the tickets. Then he goes to rent a limo, and the rental line is really long, but eventually he does it. Then he goes to buy her flowers, and the line at the florist is really long, but he finally gets the flowers. So then at the prom, she asks him to go get punch, and he goes to the refreshment table, and there's no punch line. I love that one. Okay, so I know that that felt like a long joke, and I know that oftentimes word problems feel very long, but I'm going to show you how to get through word problems. And one of the things that I've noticed over the years, honestly, is that people will tell me, they will say, you know, I'm terrible at math, and they'll say, I can't do word problems, and because I can't do word problems, that means I'm terrible at math. And I'll say, well, you know what? If I took the word problem and I wrote the equation for you, could you solve the equation? And they go, well, yeah. And that's what most, you're probably saying, you're right there, you're probably saying, if you wrote the equation for me, I could solve the equation. I can do that. And you know what that tells me? That says you're actually very good at math. You're just having trouble with reading comprehension. And I'm not saying that you can't read. I'm not saying that you're a bad reader. I'm just saying that taking the words and translating them into the math symbols, that's where the struggle is. So I'm going to get you really good at being able to translate these words into those equations, into those math symbols, perhaps inequalities, and then we're going to be able to solve them. So let's take a look at first the rule of thumb for getting through word problems. Honestly, the biggest thing is to just slow down. People put up that mental block. They put those blinders on and they put the headphones on their ears. They just block their ears and say, I'm not going to do it, I'm not going to do it. But honestly, if you will just read the problem in its entirety one time, just to get a feeling for what's happening, and then take it one sentence at a time slowly, and just take it easy, you'll get there. So we're going to do several word problems today. I probably have a dozen word problems to get through, and I'm going to show you what I'm talking about. So here's our first example, and like I said, read it in its entirety one time just to get a feeling for what's happening. So one season, Reggie Walker scored 9 more than twice the number of runs he batted in. He scored 117 runs that season. We want to know how many runs did he bat in. So we've read it in its entirety to get a feeling for what's happening, and we know that what's happening here is Reggie Walker, we're talking about the number of runs that he batted in. So let's look at this and let's break it down sentence by sentence. The first sentence says, he scored 9 more than twice the number of runs he batted in. So what we know by 9 more, that doesn't indicate some kind of inequality like this kind of more symbol. It indicates we're taking the number of runs he batted in and we're going to add 9 to it. So I know that I'm going to add 9 to something. I've got to figure out what am I adding 9 to. Well, it says 9 more than twice the number of runs batted in. Now you know that when we say twice something, that means 2 times that. So we need to figure out, okay, how many runs did he bat in? Do we know, because we know we're going to do 2 times that, whatever those runs batted in is, do we know how many runs he batted in? Look through the rest of it. Actually, no. That's the last part here. How many runs did he bat in? Aha. There's the unknown. And as soon as you figure out what the unknown is, you need to define it by a variable. So what I'm going to do now is I'm going to say, okay, runs batted in, that's what I'm trying, that's my unknown. So I'm going to give it a variable. And always define that variable for a couple of reasons. One, so that the reader remembers what it's defined as, and as well so you can remember what it's defined as, because when you get to the bottom and you get your answer, you may forget what it meant. So I'm going to let an R equal the number of runs batted in. And we said that we're going to do twice that, and then we're going to add 9 to it. So that took care of the first 2 sentences, actually the first sentence. Then it says he scored 117 runs that season. Well, remember what this tells me right here. It says Reggie Walker scored 9 more than twice the number of runs he batted in. So this right here represents what he scored, and then we were told he scored 117 runs. So this is going to be 117 runs. This is 117 runs. And how do we represent that this is 117 runs? Sure, we put in equals. You just did the hard part and did a great job of it. The hard part was writing the equation. Now all we have to do is solve it. And we're very good at that part. We've been working with solving equations. We're good at this. So to get that r by itself, remember we're going to reverse the order of operations. If we knew what r was, let's say we knew it was a 10. We'd put that 10 in there, we would multiply by 2, and then we would add 9. So we're going to kick it in reverse, meaning the last thing we said is the first thing we're going to fix. Adding 9 was the last thing we said, so we're going to subtract 9 from both sides because of the pan balance idea. That leaves me with a 2r over here, and on this side 117 minus 9 is 108. And now we know at this point we're going to go through and we're going to divide by 2. And so that tells me 108 divided by 2 is 54. So my r is 54. Now, because this is a real world situation and we're not just solving these arbitrary abstract equations, this represents something. So we need to give it its units. So this is 54 what? Well, remember, there's one of the reasons you defined your variable. R was the number of runs batted in. So it's going to be 54 runs. And always include your units for 2 reasons. One, so that the reader knows, oh, it's runs. It's not bats. It's not bases. It's runs. The other reason is to make sure that the reader knows that you know that it's runs and not bats or not bases. Very important that the reader knows that you're smart. Show how smart you are. You know it's not bases. You know it's not bats. You know it's runs. So put the units in there to prove how smart you are. Okay, let's try a few more. Like I said, I've got lots of examples of these because word problems is where people really break down and really have a rough time. So I've got lots of examples we're going to go through. So the next one, read it in its entirety. Heather bought a winter coat for $6 less than half its original price. Heather paid $65 for the coat. What was the original price? We've read it in its entirety to get a feeling for what's happening. Now we're just going to take it slow, sentence by sentence. So she goes shopping. She's getting a discount. Now discount represent what? When you go to put that coat up there, discount's going to mean what? Yes, they're subtracting. They're taking off the price. So let's go with this idea. I know some way, somehow I'm going to be subtracting. Let's go back and read it slowly, sentence by sentence. So Heather bought this winter coat for $6 less than half its original price. So what happens here is that $6 less, again, that's not an inequality symbol that looks like this. That means that when she puts that coat up there, they're going to take $6 off. They're subtracting $6. So I know that that's what's being subtracted is that $6. I've got to figure out $6 subtracted from what? Well, it's $6 less than half its original price. Aha! We're going to do half of something. Half of means multiplication. So we're going to take half of the original price and we're going to subtract $6 from that. All right, great. Do we know what the original price is? So that we can take half of that. Well, it says Heather paid $65 for the coat. That's not the original price. That's her final sale price. And it says, what was the original price? Okay, we don't know what the original price is. There's our unknown. And when you figure out what that unknown is, define it with a variable. So let's and I like to be creative. If I'm talking about a price, I'm going to use P. Let P equal and I'm going to call it original price. A lot of people will try to use an O because of original, but be very careful because if you call it an O, when you put an O in there, that might look like a 0. So I try to avoid O's. But there's the original price. Remember, we said we're going to take half of that. So half of means multiplication, half of the P, and then we said we're going to do $6 less than that much. So we're taking $6 away. Now, that takes care of the first sentence. The next sentence says Heather paid $65 for the coat. Now remember, when we take $6 off of half that original price, that is the sale price of the coat. But we were just told that sale price is $65. How do we represent is $65. Absolutely. Is represented with an equal sign. And voila, there it is. You just did the hard part and did a great job of it. Now, let's solve it, which I know you can do. And once again, if I knew that P was a 10, order of operations, correct order of operations would say let's multiply first, then subtract a 6. Kicking it in reverse means I'm going to fix the last thing I said. The last thing I said was subtract 6. So I'm going to add 6 to both sides, giving me a half P. And on this side, I'm going to get a 71. And now what I'm going to do is divide by a half. Now, we've talked about this before, that this works all well and good because the halves cancel, but look what a complicated fraction that is. That is what we call a complex fraction, which are kind of cumbersome to deal with. But remember, we said before that dividing by a fraction is the same thing as multiplying by its reciprocal. So I'm going to go for the jugular. Much cleaner, much faster. Rather than dividing by that fraction, it's cleaner and faster to just multiply by its reciprocal. Because remember, when you multiply fractions, there's that silly gang symbol again. Multiplying fractions means cancel on those diagonals. So these are going to cancel out, and I am left with that P. But what I do on one side, I got to do on the other side. So I'm going to take this side and multiply it by 2 as well. And 71 times 2 is 142. Once again, need to include those units because this is a real world situation, not some abstract equation. So that's 142 what? Is 142 coats? What is it? Once again, great reason for defining that variable. If I look over here, P was the original price. Oh, it's not coats, it's dollars. So $142 is my answer. Excellent job. All right, let's take a look at one more. And like I said, several more after this one. Let's just keep trucking on through them. The grossman's total dinner bill at a restaurant was $52.44. It included a 15% tip. What was the cost of the dinner before the tip? Okay, it's date night. This is not McDonald's. This is a nice restaurant where we include tip. So we've read it in its entirety to get a feeling for what's happening. Let's break it down sentence by sentence. Let's think about this idea of tip. How does tip work? So what you do is you take the cost of the meal and then you do a percentage of that cost and you add that to the cost of the meal. So I'm going to take the cost of the meal and I'm going to add the tip amount, and that's going to give me the final bill. Well, that's if no sales tax is included in there. But we said to get that tip amount, remember that's going to be a percentage of the original cost of the meal. Of always means what? Multiplication. So let's go through this now, sentence by sentence. So the gross, because we now have a feeling for what's going to happen here. So the total dinner bill was $52.44. Now is that this, the cost of the meal, or is that this, the final bill? Yes, that's the final bill. So that $52.44 goes right over here. And now what I'm going to do is I'm going to say, okay, let's take that next sentence. That includes that 15% tip. Okay, now remember, it's 15% of the cost of the meal. So we need to figure out, do we know the cost of the meal from the beginning? And as I look, no. I mean, the next question says, what was that cost of the meal? So there's my unknown. And remember, when you figure out what that unknown is, define it by a variable. So I'm going to let's go with an M. Let M equal the cost of the meal. So what happens here, there's the cost of the meal, which is now an M. But remember that tip amount is going to be 15% of this. So 15% times this. And we know that we can't work with 15% this way. We have to turn it into a decimal. Decimal point is currently in the back. We're going to slide it 2 to the left, giving me a 0.15 M. So here we have it. Cost of the meal plus the tip amount gives us our final bill. There you go. And that is how you set it up. That's the hard part. Now the easy part is just solving it, and you're very good at that. Notice that what I'm going to do here is I'm going to combine my like terms. I didn't do this here. I didn't do it previously because this side was as simple as it was going to get. I had no like terms that I could combine, nor did I in the first problem. This one, however, I do have a couple of like terms here. This is 1M plus 0.15M. And when you combine those two, you get 1.15 m. And now you know what to do. You know to get that m by itself, all you have to do is divide both sides by 1.15. And 52.44 divided by 1.15 is going to be a 4560. And once again, I need to include those units. Very important that you include the units. One, so that the reader knows, and is this stakes? What is this? But more than that, so the reader knows that you are smart. You know what this is. Go back and how did you define it? M was the cost of the meal. So therefore, it's going to be dollars. Now, it's a good idea to always go back and double check before you circle it, which I've not done yet. But it's a good idea to go back and double check. Did I actually answer what I was supposed to answer? Because sometimes what you're supposed to answer is not quite the variable. It's more than that. But we need to get the variable in order to get to the answer. In this case, we were asked what was the cost of the dinner before the tip. Okay, that's what this was. And in this one, we were asked what was the original price. There again, that's what we found. And in the previous one, we were asked to find how many runs he batted in, which was the variable that we defined. So we did answer the things that we needed to answer. All right, let's take a look at a couple more. Okay, so let's try a few more of these word problems because you know that I like to get you really good at these. So like we said before, read it in its entirety once just to get a feeling for what's happening and then take it very slow sentence by sentence. So the next one says, at some hotels, senior citizens get a 20% discount on a room. If the discounted price is $78 for that room, what is the regular price? So we've read it in its entirety. We get a feeling for what's happening here, that we're going to get a discount. And let me tell you, getting old is for the birds. At least I get to look forward to my senior citizen discount. At least I've got that coming to me. But anyways, so we know that what happens with a discount? Exactly. That means a subtraction situation. We're deducting something. So I'm going to be taking away some way, somehow. Now, now that we've got that general idea, let's go slowly, sentence by sentence. So it says, at these hotels, the senior citizens get a 20% discount on that room. So what that means, remember, is we're going to do 20% of something. What are we doing 20% of to get that discounted amount? Yes, we're going to do 20% of that original price. So we need to figure out what happens here is we are going to take that original price, and we are going to subtract that discount amount. And when we do that, that will get us that final price. That's what happens when they take that deduction. And we just said that that discount amount is going to be 20% of the original. So the question is, do we know what that original amount is? As you look through here, do you know the original amount? No, because this $78 is the final price, because it says if the discounted price is $78, that's the final price. That's what goes over here, the $78. So this 20% of the original, I don't know what the original is. Aha, there's the unknown. And remember, when you figure out what the unknown is, define it by a variable. So let's go with P. Let P equal that original price. Like I said before, I try not to go with an O because oftentimes an O looks like a 0. So I'm going to let P equal that original price, and that's going to go right here because we're going to take that original price, we're going to subtract the discounted amount, and remember, to get that discounted amount, that's 20% of, and what does of mean? Yes, of means multiplication. So it's going to be 20% times this P. But as we've discussed before, that 20% can't leave it as a decimal. Or I'm sorry, can't leave it as a percentage. We've got to turn it into a decimal. So the decimal point is currently in the back. We're going to slide it 2 to the left, giving us 0.20. So we're going to take that 0.20 and we're going to multiply it to that P. That is the discounted amount. That's the amount that they're taking off. So now what's going to happen is we're going to combine up our like terms, because remember, now we've done the hard part. We've set up the equation, and we did a great job of setting up that equation. So what we're going to do now is simplify our equation and solve for that P. So what we have to do is we have to shave this down and simplify, which means we're going to combine up our like terms. This is 1p. We're going to take that 1p, we're going to subtract a 0.2p. Now 1p minus 0.2p is going to be a 0.80p. And so now all we have to do to get that p by itself is we just simply have to subtract, or not subtract, I'm sorry, divide by 0.80. So 78 divided by 0.80 is a 9750. And so that is going to be the p. Now remember, I said that whenever you're in a real world situation like this, we need those units for a couple of reasons. One, so that the reader knows, are these 97.50 rooms, 97.50 beds, 97.50, what are they? 97.50 what? Go back to what you defined your variable as. That P was the original price. Oh, so that means these are dollars. So one, the reader knows that that's $97.50, but two, and more importantly, the reader knows that you know these are $97.50. It's very important the reader knows how smart you are. Show that off and put those units in there. Now, we need to double check and make sure that we actually answered what we were supposed to answer, because sometimes the variable is just kind of an embedded part and it's not really the answer we're looking for. So go back and check, if the discounted price is $78 for that room, what is the regular price? Aha, that's what we did find was the regular price. So we know that we answered what we needed to answer. All right, let's take a look at another one. We're getting good at this. Freddie now weighs 260 pounds. To weigh 190 pounds in half of a year, how much weight must he lose per week? So we've read it in its entirety to get that feeling for what's happening. Now what we're going to do is just take it slowly, sentence by sentence. What he's doing is he's starting with a certain amount of weight, so that would be his beginning weight, and he wants to lose a certain amount of weight. So when we lose weight, we're taking it off. So he's going to take off a certain amount of weight, and in the end that'll give us his final weight. That's the grand idea here, the big idea of what's happening. And now we're going to take it slowly, sentence by sentence. So he now weighs 260 pounds. Aha, that's that beginning weight. And it says he wants to weigh 190 pounds in that half a year. That's his final weight. In the end, he wants to be 190 pounds. Now, this idea of the half a year, what that means is, notice it also says, how much weight must he lose per week? So he's going to lose a certain amount of weight each week, and this is going to last for half of a year. So the big question is, if it's lasting half a year and this is happening weekly, well, how many weeks are in half a year? Well, there's 52 weeks in a year, which means 52 divided in half would be 26 weeks out of a year. So he's going to lose a certain amount of weight. He's going to do it for 26 weeks. Well, how much weight is he losing each week? That's the unknown. There's my variable. So once we've identified what the unknown is, we need to define it by a variable. So let's pick a variable to stand for the amount of weight he's going to lose each week. I like to be kind of creative. I'm going to use a W for weight. That way it's easy for me to remember. So let W equal the amount of weight lost each week. Amount of weight lost each week. So what happens here is, remember, that's going to be a certain amount of weight lost 1 week. Let's say he loses 2 pounds in 1 week. That means in the second week it's 2 plus 2 more. Third week, 2 plus 2 plus 2 more. Fourth week, 2 plus 2 plus 2 plus 2 more. So we're adding 2 each time, but what would be faster than adding 2 over and over and over again? Like in that fourth week, instead of adding 4 2's, what's faster than that? Certainly, multiplying by 4 is faster. So what we're going to do here, just to speed things up, is we're going to multiply by the number of weeks to this amount of weight that he's losing each week. How many weeks is this lasting? Oh yeah, 26. So we're going to take the 26 weeks, multiply it to the W. That's the total amount of weight that he's going to lose. So this 26W, the total amount of weight that he's going to lose, is going to go right here. That's being taken away from that 260. And we just did the hard part. We set up our equation. Now all we have to do is solve it. So notice that all the variables are here by themselves. That means we need to slide all the constants over to this side. Take that 260 out of there, so I'm going to subtract 260 here. I'm going to subtract 260 here. That leaves me with a negative 26W here. And on this side of 190 minus 260 is a negative 70. Now what do I have to do to get that W by itself? Just simply divide by that negative 26. So when I take a negative 70 and divide it by a negative 26, I get about 2.69. Now that's not exactly 2.69 like our previous questions have been answered. Instead, this is rounded to 2.69. I rounded that decimal value. So it's approximately equal to. So I'm not going to put an exact equal sign. I'm going to put an approximately equal to sign in there. And once again, what are my units? It's a real world situation. I have to make sure that the reader knows what the units are, and that more importantly, I show off how smart I know that how smart I am, that I know what those units are. So let's go back to what we defined. W was weight. The weight is in pounds. We're in the standard U.S. customary units, so it's going to be 2.69 pounds. Now, just double check that we actually answered what we were supposed to answer. The question said, how much weight must he lose per week? That's what we answered, 2.69 pounds. So we know that we've answered correctly what we're supposed to answer. All right, let's try a couple more. You know I've got lots of these to get us really, really good at it. Okay, read it in its entirety to get a feeling for what's happening. At the You Pick Strawberry Farm, Susan paid a total of $5.59 for the following: 55 cents for an empty basket, and then 48 cents a pound for the strawberries that she picked. How many pounds of strawberries did she pick? Okay, so we've read it in its entirety to get a feeling for what's happening. Now what we're going to do is just get that general sense that what happens here is when she goes, she gets an empty basket, and then what she does is she takes that empty basket and she adds to it the strawberries. And once she adds those strawberries in there, that's going to give her her total price. So let's take it sentence by sentence very slowly. So at the beginning, at that U-Pack Strawberry Farm, it says $5.59. That is her total. That's that final price that we were talking about, $5.59. Now, let's take the rest of it slowly again. 55 cents for an empty basket. Okay, there's my empty basket of 55 cents. And now let's go with, it's 48 cents per pound of strawberries. Okay. Like we had said previously, if it's 48 cents on the first pound, and then in that second pound we're going to add another 48 cents, and then in that third pound we're going to add another 48 cents, in other words 3 of those, and in the fourth pound another 48 cents, 4 of those, rather than adding 48, 48, 48, 48, what would be faster? Exactly, to multiply by the number of pounds. So the question is, we're going to take this 48 cents and we're going to multiply it by the number of pounds. Do we know how many pounds? No, we don't. Aha, there's our unknown. And as soon as you figure out what that unknown is, define it by a variable. So and again, let's be kind of creative here. Let's go with P equal the pounds. And that'll be pounds of strawberries. So we said that we're going to take this 48 cents, we're going to multiply it to the number of pounds, which would be P. So that would be 0.48 P, and that's going to be the cost of the strawberries. So we're going to take the empty basket, add in the cost of the strawberries, that'll give us the total price. And ta-da! We just did the hard part. Now all we have to do is solve it. So just like before, all the variables are here by themselves. We need to put all the constants together on the other side, which means let's take that 55 cents out. And when we take a 5.59 minus a 0.55, that will give us a 5.04. So now to get that P by itself, what do? Exactly. We're going to take that 0.48 and we're going to divide both sides by 0.48. And so that means I'm going to take my 5.04 and divide it by 0.48. And 5.04 divided by 0.48 is a 10.5. So that is our P. But once again, real world situation, what is this 10.5? What? Go back and look at that variable, pounds. Okay, 10.5 pounds of strawberries. Now let's go back and let's double check. Did we answer what we really were supposed to answer? How many pounds of strawberries did she pick? Yep, we answered it exactly the way we were supposed to. All right, hopefully you're feeling good, so let's keep going. Ms. Gowan sells stereos. She gets a salary of $250 a week and a 5% commission on her total sales. If she earned a total of $400 one week, what was the total of her sales? So we've read it in its entirety. We've got this feeling for what's happening. She's on a commission job. So do you know how commission works? The way commission works is you have a base salary, and then what you do is you take that base salary and you add to that the commission amount. And your commission is a percent of your sales. Once you take your base salary and you add to it the commission, that will give you your paycheck for the week, month, whatever it may be. But that will be your paycheck. This is how commission works. That commission is a percentage of your sales. And you know that in math, of means what? Exactly. It means multiplication. So we've got this feeling for what's happening. Let's go slowly, sentence by sentence. So she sells her stereos. She gets a salary of $250 a week. Now the question is that $250, like, are we talking about 1 week so that $250 would be a flat rate? Or are we talking about like a paycheck that's for the month? In which case we would need to multiply 250 by 4 for 4 weeks in the month. What are we talking about here? Let's continue to read. 5% commission on her total sales. She earned a total of $400 1 week. What was the total of her sales? Okay, so we are talking about a paycheck for 1 week's worth of work. So this $250 flat rate salary, we don't need to multiply it by anything because we're just talking about 1 week's worth of work. So that base salary of $250 will go right here. Now, next it says that she has that 5% commission. Well, 5%, remember it's 5% of something, and we said commission is 5% of her sales. And you know that of means multiplication. You know that you can't use it as 5 in terms of 5%. You have to turn it into a decimal. So I'm going to slide that decimal point that's currently in the back, slide it 2 to the left, giving me 0.05. So it's going to be 0.05 times the sales. Well, how much sales did she have? Let's see here. If she earned a total of $400 and what? Okay, that's not her sales. $400 is not her sales. That's actually her paycheck. So that will go here, which means no, we don't know what her sales are. So let's get a variable because, aha, there's the unknown. So let's go with a T for total sales. So T is going to be her total sales, and we said that commission is going to be 5%, 0.05, times this total sales. So 0.05 times her total sales, that's her commission salary, plus her base salary will give her her paycheck. So ta-da! We just did the hard part. And you know how to solve this. You know that all the variables are collected here, which means all the constants need to go to the other side. I'm going to slide that 250 over and subtract it off. And 400 minus 250 is going to be 150. So that gives me a 0.05 T equal to 150. And we now know that in order to get that T by itself, we just simply have to divide both sides by 0.05. And 150 divided by 0.05 is 3,000. And so that's going to be my T. But 3,000 what? 3,000 stereos, 3,000 weeks, what is that? Again, that's the value of defining that variable. T is total sales. Sales is going to be in dollars. Show how smart you are and include those units in there. Now, did we answer what we were supposed to answer? If she earned a total of $400 1 week, what was the total of her sales? Yeah, that's exactly what we answered. That we got the sales. Okay, we've just got a few more and then we're going to be done because I want you to be really, really good at this. And that's why I've got tons of examples. Lots of people really struggle with word problems. And so I like to give as many examples of word problems as I possibly can just to make sure we're really good at it. So here come a few more. All right, just 5 more to go. So we're going to read it in its entirety, again, just to get a feeling for what's happening, and then we're going to break it down sentence by sentence very slowly. So the next one says, we've got this rectangular field. It is 5 times as long as it is wide. And if the perimeter of the field is 288 yards, what are the field's dimensions? Okay, so we've read it in its entirety to get a feeling for what's happening. And folks, I'm here to tell you that if you can draw a picture is worth 1,000 words. A lot of people are kind of scared to draw a picture, but listen, I'm the one with the master's degree in math. I'm the teacher. I'm going to draw a picture every single time. So here is my rectangular field, okay? And now let's talk about what's happening here, that general big idea feeling. So it's talking about perimeter. Well, what is perimeter? How do you get perimeter in a rectangle? Yes, perimeter is the distance around. So what it takes to get the perimeter of this is to be able to add up all the sides. In other words, I'm going to take the length and the width and the length and the width, and I'm going to add them all up, and that's going to give me my perimeter. Length plus width plus width. But what would be faster and frankly a little bit cleaner rather than length plus length? What's faster than that? Sure, we've talked about this before, doubling that length. 2 times the length. So therefore, what's faster than W plus W? Absolutely, 2 times W. So folks, this is your perimeter formula. Double the length, double the width, and that gives you your perimeter when you have a rectangle. So we're going to use this perimeter formula in this situation because we are told that's what we're dealing with. The perimeter of the field is 288. So if we already know that this perimeter is 288, we can go ahead and put that in there. So we now have 288 equals double the length plus double the width. The only problem with this is I still have 2 variables in there. So I can't solve the equation when I have 2 variables. I've got to narrow this down to 1 variable. So let's take it slowly, sentence by sentence. The rectangular field is 5 times as long as it is wide. 5 times as long as it is wide. Here's where things get a little bit tricky. So we have to take that and we have to go back to this picture and we have to say, okay, if this says it's 5 times as long as it is wide, do I have my picture labeled correctly? In other words, does that mean that the length is bigger than the width? Or is the width bigger than the length, in which case I've got my picture labeled incorrectly? Which is bigger, length or width, based on what this says? 5 times as long as it is wide. Absolutely, the length is bigger than the width. So what now it tells me is, what's it going to take this 5 times? Does that mean I'm going to multiply 5 times the length, 5 times this great big length, to make it the equivalent of this little itty bitty width, or 5 times this little itty bitty width to make it the equivalent of this great big length? In other words, would I take 5 of these widths, 5 times 5 of these widths, to make the same amount as this length that's bigger? Or would I take 5 of these lengths, 5 times them, 5 of these lengths together to make the equivalent amount as this little itty bitty width? Yes, it would be 5 times these little widths to have the same amount as the length. So what that tells me is that that length is going to be 5 times the width. L is 5W. Why am I doing that? Why does that help? Oh, yes, you're right. Because that means that this 5W right here, everywhere I see an L, I can put a 5W in its place. So that means I'm going to take this 5W, I'm going to put it right here where this L is. And when I do that, instead of having 2 times L, I now have 2 times 5W. But the beauty is, take a look at that equation now. Yeah, I've only got 1 variable. And when I have 1 variable, I can solve the equation very easily. Because I know that 2 times 5W is going to be a 10W. And I know that if I have 10 W's and 2 more W's, that means I have 12 W's. And we know now, in order to get that W by itself, all we have to do is divide by that 12. And 288 divided by 12 is going to be a 24. And that's going to be my W. But we've talked before about the need of units because this is a real world situation. 24 what? Yes, 24 yards right there. So my width is going to be 24 yards. And we need to figure out, okay, did we answer the question that we were supposed to answer? It says if the perimeter of the field is, and we used every sentence. We used the first sentence, 5 times as long as it is wide. Second sentence, if the perimeter of the field is 288 yards. We've used everything we needed to use. And now what are the field's dimensions? Well, we got the width. We now need to get the length. How would we get the length? Oh, yeah, absolutely. Just multiply it by 5. So to get that length, we're going to do 5 times 24. And I'm very sorry, I'm running out of space here. This is very, very congested, and I'm so sorry. But 5 times 24 is going to be 120. And again, that's 120 yards. And that's going to be my length. I now have the field's dimensions. Now, how can I check to make sure that I'm right? Because it's a good idea to check these and make sure that we're right. Sure, yes, we could take 24 and multiply it by 5 to get 120. Well, that's how we got 120. But how else could we check? Absolutely. Double that length, double that width, add it all up, we better get 288. So when we double that length, 2 times 120 is 240. 2 times 24 is 48. And 240 and 48, yep, gives me 288. So I know that it's right. All right, well done there. Let's try one more. So we've got this baseball court, or sorry, not baseball court, a basketball court, and it's a rectangle with a perimeter of 86 meters. Aha, dealing again with perimeter, dealing again with a rectangle. So once again, that picture's worth 1,000 words. I'm going to go ahead and draw that rectangle. And because I know I'm dealing with perimeter, which means add up all the sides, I'm going to use this perimeter formula right here. P equals double the length, double the width, add it all up. Now, let's continue on here. The length is 13 more than the width. Find the length and the width of the basketball, good grief, basketball court. Very similar to the previous problem we had. So, we are told the perimeter is 86. That means I'm going to take that 86, put it right here where the perimeter is. 86 is 2L plus 2W. And just like before, I still have 2 variables, so I can't do anything with it. I need to figure out one of those variables. So let's go with that second sentence because we've used the first sentence now. The second sentence says that length is 13 meters more than the width. Length is 13 meters more than the width. So we have to decide, does that mean that the length here is bigger than the width, or do I have it labeled incorrectly and the width is going to be bigger than length? Which one is bigger based on what this says? The length is 13 meters more than the width, which is bigger. Yes, I've got my picture labeled correctly. The length is bigger. So now the question is this idea of 13 meters more. Now that's not one of those inequality kind of situations where we're looking at this sort of thing. 13 meters more actually means what? Yes, it means I'm going to add 13. So the question is, does that mean take this little width and add 13 to it, stretching it out like this, so that it'll have the same amount as this length? Or does it mean take this length and add 13 to it, stretch it out this way, so that it'll have the same amount as this little itty bitty width? Which one are we going to add 13 to create the same amount as the other one? Yes, we're going to add 13 to the width. So that L is going to be width plus 13. And just like before, why did I do that? Why does that help? And yes, just like before, it's because everywhere I see an L, I can take this W plus 13, I can put that in its place. So that W plus 13 is going to go right there where that L is. So now instead of 86 equals 2 times L, it's going to be 2 times, now be very careful here folks, it's 2 times all of this. Not just the W, but all of this. So how do we show that it's 2 times all of that? Yes, I'm going to put a parentheses around it and write it this way. 2 times not just the W, but the 13 as well. And then don't forget this 2W that's in the back to have that full formula. And the beauty is we now only have one variable. We are good to go at this point. So to solve this, you know that what you're going to do is distribute that 2 through, giving you 86 equals 2W plus 26, plus that other 2W in the back. Don't forget that one. And now we know that we're going to combine up our like terms. And we've got a 2W and a 2W, and that'll give me a 4W. And we know now that all of our variables are over here on the right, which means get all the constants over there on the left. Let's subtract that 26 and subtract that 26. 86 minus 26 is 60. 60 is 4W, and we know now to get that W by itself, let's just go through and divide by 4. And 60 divided by 4 is going to be a 15. And that is my width. But once again, real world situation, what are those units? We've got to be smart. Show how smart you are. That's 15. I mean, this one was yards. Is it still yards? Nope. Meters. So put those units in there. But this is 15 meters, and that is my width. And once again, let's go back and check. Did we answer everything we were supposed to answer? We were told find the length and the width. We only found the width. We've got to get the length. So here's how we find that length. Just take that W, which is 15, and add 13 to it. So my length then is going to be 15 plus 13, which is 28. And once again, put those units, 28 meters. And just like before, how would we check to make sure that we're right? Yes, just like before. Double the length, double the width, add it up. I better get an 86. Well, if I double 28, that gives me 56. If I double 15, that gives me 30. And what's 56 and 30? You guessed it, 86. So we know that we did it right. Now, one thing that I want to mention before we get into the last three examples is I keep talking about using every sentence and taking it very slowly, sentence by sentence. Using every sentence, I say use every sentence, but it might not be that the information in that sentence needs to be used in the problem. In the cases that we've had, yes, every piece of information has been used, but there are times that you'll see some numbers that are not going to be useful at all. So this is why it's very important to get that big idea picture. And like I said before, get that picture in there. Draw a picture. It's worth 1,000 words. Get that basic formula. Get the basic idea, like we had said, perhaps the original cost of the room minus the discount amount will be the final price. Or with the commission idea. She has her base salary plus her commission amount, gives her paycheck. Get that big idea going so that you can fill in those gaps. That will help you to see if certain numbers in the problem are useful or not useful, because it's not always going to be that you will use every number that you're given. Some of them, just chuck them. Some of them don't even use them. So with that in mind, let's take a look now at these last three examples. You're going to see a strange thing happening with these last three examples, because this problem says, okay, we want to look at the idea of consecutive integers. It says find 3 consecutive integers whose sum is 96. Now first off, what does sum mean? Yes, sum means addition. I'm going to take 3 integers, 3 numbers, and add them together to get a 96. But here's the key word, consecutive. What does consecutive mean? Yes, consecutive means come one right after the other. So in other words, if I start with one integer, like say for instance a 10, what's a consecutive integer after that? Yes, 11. What's a consecutive integer after that? Yes, 12. So they come one right after the other. So I need 3 numbers that come one right after the other. They're going to add up to be a 96. Well, I don't know what my starting point is. I don't know what any of these numbers are. So let's get a variable. We'll go with the proverbial x. And that's going to be my first integer. Now the catch is I'm going to take this x and I'm going to add something to it. And in the end, I'm going to get a 96 out of that. But what am I going to add to it? Now remember, the next one that comes after, let's think about the example that I gave you. If you start with a 10, how do you go from 10 to 11? Exactly, you add 1. So what that means is I'm going to take my first integer, I'm going to add 1 to get to the next integer. I don't know what the first integer is, I called it an x. But what I do know is I'm going to take that x, I'm going to add 1 to get to the next integer. So I'm going to say x plus 1 is going to be the second integer. Well, that means that I'm going to take an x plus that second integer of x plus 1. But remember, I'm going to add that third integer in there. Now, to get to that third integer, let's think about this. 10 plus 1 gives me 11, plus another 1 gives me a 12. So basically what that means is take this second one, x plus 1, and add 1 to it. But basically, x plus 1 would be what? Exactly, it would be x plus 2. And that's going to be that third integer. And if you think about it, go with the 10, the 11, and the 12. Sorry, spelling wrong now. Integer. Think about the 10, 11, and 12. How did I go from 10, the first integer, to 12, the third integer? 10 to 12 would be adding 2. So you take your first integer and you add 2 to skip over and get to that last integer. So here's my first integer, here's my second integer, and let me clean this up a little bit, it's kind of hard to see. First integer, second integer, and here is that third integer. And I'm going to add them all up to get a 96. You just did the hard part. You set up your equation. Now all we have to do is solve it. So what we're going to do is combine up our like terms. Understand that the only reason I put these parentheses in there is just simply to show that this represents the second integer, this represents the third integer. They don't really need to be in there. It could just look like this. And that perhaps makes it a little bit easier to combine up those like terms, where I have an x, and another x. That gives me 3 x's. And then what I'm going to do now is combine up the 1 and the 2. 1 plus 2 will give me 3. So I have a 3x plus 3 giving me a 96. Ta-da! All right, we're cruising now because all the variables are on this side. We're going to slide all the constants to the other side. You know that means subtract the 3, giving me 3x equals 93. And you know at this point, to get that x by itself, all you have to do is go through and divide by 3. And 93 divided by 3 is a 31. So that first integer is going to be a 31. Now, to get the second integer, all we have to do is add 1 to that. So 31 plus 1 gives me 32, and that is my second integer. And then you know that to get that third integer, all we have to do is take our 32 and add 1. And 32 plus 1 will give me a 33. There is my third integer. Now, how could we check to make sure this is right? Well, certainly they're consecutive. 31, 32, 33. So check on that one. We've got this portion of it right. And now we just need to check, do they add up to 96? If you take a 31, a 32, and a 33, do they total 96? Yes, in fact they do. So we know that these are the 3 consecutive integers whose sum is 96. Beautiful job. Okay, now the next one has a similar idea because you see that word consecutive and you do see the word sum. We know that we're adding them up. This time we're only adding 2 integers, but notice the big difference right here with odd. I want 2 consecutive odd integers whose sum is 76. Odd integers. So let's think about odd integers. So this time I'm not going to start with a 10. I'm going to start with an 11. Now what is the next odd integer after that? Consecutive means come right after that. But see, if you come right after 11, you hit a 12. That's even. I want the next odd integer. So I'd go from an 11 to a 13. Now the catch is, how do I go from 11 to 13? Exactly, I add 2. This is what makes this one hard because a lot of people, they go, okay, I got this. Let's let x equal that first integer. They have no problems with that at all. But they think, okay, consecutive means let's just add 1. But if I simply add 1 to it, and I start with an 11 as my x, that means this is 12. And that's not odd. So instead of adding 1, I have to add 2. And that will be my second integer. Feels very weird because 2 is an even number, so you feel like that's messing it up. But actually what adding 2 does is it allows you to skip over a spot. Because if this is my first spot, and this is my next consecutive spot, if I want to skip over it to here, then instead of adding 1, I have to skip over it and add a 2. So adding 2 allows you to skip over a spot. So we now have those 2 integers, and we're going to add these 2 up. There's the first one, here's the second one. They're going to total 176. And like I said before, the only reason that I put the parentheses there is just to know that this is that second integer. It doesn't really have to be there. And now I'm ready to combine up those like terms. An x and an x will give me 2x. And now what do I have to do to solve that? Because notice that all I need at this point is to subtract that 2. And when I subtract the 2, I get a 2x equals 174. And now just go through and divide by 2. And when I divide by 2, that x is going to be an 87. So there's my first integer. And now to get that second integer, we know that we're just simply going to add 2 to that. So when we take an 87 and we add 2, that's going to be an 89. And that's going to give me my second integer. Now let's double check. Are those odd integers, 87, 89? Sure are. Are they consecutive integers? Yep, because after 87 will be an 88, but that's not odd. So it'd be 87, 89. Do they total 176? Yep, they do. So we know that it's right. All right, I think you're getting the hang of it. So let's try this last word problem. Once again, consecutive. This time they're even integers. And once again, sum to be 396. So we know that we're going to start with, let's let x equal that first integer. Now, remember, even. So some people get confused. They say, well, if I added 2 for those odd ones, that must mean that I add a 3 or add a 1. But again, let's play with some numbers here. If 10 was my first even integer, what would be the next even integer? It would be 12. And then after that would be 14. So to go from a 10 to a 12, what do? I add 2. Again, this idea of adding 2, all it does is allows you to skip a spot. So that means I'm going to take this first integer and I'm going to add a 2. That'll give me my second integer. But then I have to add 2 again to skip a spot. So I'm going to take that second integer, x plus 2, and I'm going to add one more 2 to that. And that gives me x plus 4. That's going to be my third integer. And let's think about that one more time. Start with a 10. Add 2 to get to the 12, which is the next one. Take the 12 and add 2 to get to 14. How do I go from 10 to 14? Yes, I add 4. So I'm going to take my first one. I'm going to add 4 to get to that last one. Now, all we're going to do at this point is we're going to take those 3, my x plus my x plus 2, plus my x plus 4, add them all up, and I'm going to get a 396 out of that. And like I've said many times, the only reason I have the parentheses there is just to let me know that this one's that second integer. I don't really need the parentheses. This one's that third integer. I don't really need the parentheses. And now I'm ready to combine up those like terms. So we have an x plus an x plus an x. That's 3 x's. And we've got a 2 plus a 4 gives me 6. And now we know in order to solve this, let's slide that constant over, giving me 3x equals 390. And we know at this point, just go through and divide by 3. And 390 divided by 3 will give me 130. There's that first integer. Second integer means add 2 to that. So x plus 2 will be 130 plus 2 will give me a 132. There's my second integer. And then my third integer, we're going to add a 4. So let me go this way. Oh, this is awful. We'll take that 130 plus 4, and that'll give me a 134 for that third integer. Once again, are they consecutive? 130, 132, 134? Yes, they are. Are they even? 130, 132, 134? Yes, they are. Do they total 396? 130, 132? Well, 2 and 4 is 6. 3, 3 and 3 is 9. And 1, 1 and 1 is 3. 396. Yep, sure does. So I hope that helps with the word problems. That's the one area where people really struggle, is taking these words and translating them into variables and numbers and equations and all kinds of mathematical representations. Like I said, read it in its entirety one time just to get a feeling for what's happening. Don't be afraid to draw a picture, because a picture is worth 1,000 words. Write down the general idea, the big picture idea of what's happening, even if that big picture idea is in words like we saw. Original price minus discount equals final. Or we said empty basket plus strawberry poundage equals total bill. Write down the big idea and then just go slowly, sentence by sentence. A lot of people just put blinders on and they go, I just got to get through this, and they try to barrel through it as quick as possible. Sometimes you just got to slow down. But I know you can get it. I know you've got it. And I hope it helps. Have a great day.